Okay, ji. Assalamu alaikum, everybody. Again, we are here for an MCQ past paper session, just quickly going over some tips, some guidelines, questions that are a little bit trickier. I've tried to comprise questions that are somewhat more difficult and will require a little bit more thinking out of the box to be able to get through. The objective of these questions is that not everything here is obviously you all understand absolute. Matlab beta ye hai ki so when you look at this stuff and it brings up ideas on how you go about maybe going through a question. Now, before we do anything, the one thing that I would always suggest to you all when it comes to an MCQ question is remember it's a time-based examination, right? So one of the first guidelines that you should have been taught very early when you started this idea of O-level chemistry is that it has to be about an understanding, an idea, a principle, where again, if you are going through the examination and you find yourself, particularly for, I know for the IGCSE, you guys actually have a shorter period of time than the O levels do, or it could be the same. I'm not 100% certain, but I think it's near the same. But the understanding it's that you've got to keep in mind here is that for one MCQ, 1 mark, you're looking at about a minute and a half. Now, I don't even pretend that every question will take a minute and a half, but some questions will take a lot less than that. So you've got to pace yourself. If you find yourself spending more than 2 to 3 minutes on an MCQ question, it is better in your favor to skip it and come back to it later. Because guess what? It's only worth 1 mark, right? It's better to maybe lose out on that 1 mark in like question 17 than to lose out on the last seven because you spent so long on question 17. So one thing that you've got to have in your mind is that if you find yourself stuck on a question, for some reason it won't solve, it won't go through, don't just sit there and waste time. Go on to the next question and then come back to that one if you have time in the end. Because even if it gets lost, it's only worth 1 mark. So please keep that in mind. All right, question number one. The objective of understanding here is that we're looking at a question where they have very categorically mentioned to us the actual temperature at which, again, we want these substances to be stored as liquids, right? So they've given us a temperature of negative 200 degrees centigrade and a pressure of 1 atmosphere. Now, the way you've got to think about this is that the only way that something will ever be liquid, and they love asking about liquid, by the way, is if the temperature they're giving you fits perfectly between the melting and the boiling because it has melted, it has not yet boiled. So the only ones that would have a boiling point within our melting and boiling point range is going to be with the nitrogen and oxygen. So in your mixture of three gases, only two would exist in liquid form at negative 200 degrees centigrade. So again, if they're giving you a particular value in terms of liquids, it's got to be between melting and it's got to be between boiling. Okay? All right. Question number two focuses on salt identification, salt or ion identification. Says that an aqueous ion contains a salt, Y. Again, keyword aqueous, so it's got to be soluble. Then it says that, again, an addition of an aqueous solution, X, results in a precipitate being formed that redissolves. Now, the reason I picked this question is because not that it's difficult. It's because it focuses on adding something in small amounts and then adding in excess. That's what this means when it says redissolved. That when you add a small trace amount, you see an observation. The moment you go to excess, the observation disappears. And the objective of understanding was that you can put that idea in your mind. Redissolves means that when you added more of the original solution X to Y, then the precipitate went away. So the only way that this is possible is if we're looking at D, because the cation in question is Zn2 plus. And if you remember, the only cation which upon addition of alkali forms a precipitate and then disappears in excess every single time is zinc 2. So again, the redissolves in your mind should be clicking the idea to the idea that again, it's now a little bit and then an excess. All right? Now, moving on to question number three. A couple of things to note here. It says that sulfate of Q is insoluble. Now, Just by looking at the number of valence electrons, you should already have in your mind that this is referring to group number two, because it is only sulfates of group two that are insoluble, right? Now, having said that, there's only one that is not. So the way that it works for group two is that magnesium is soluble, but by the time we get down to barium, it no longer remains soluble. By the time we get down to barium, it becomes insoluble. So again, your solubility decreases down the group. So if that's the case, if barium is insoluble and they ask us for the number of protons, then it's definitely not A or B, because A or B is referring to magnesium and not to something lower down the group. Now, the next question says that the next element R is a member of group 7. As you can see, there's 7 valence electrons. So it's a member of group 7, and it says that it's got to be gaseous at room temperature and pressure. Now, there's only 2 members of group 7, which by themselves, and by the way, don't get confused, they're not talking about the compound of the group 2, group 7 substance. They're talking about just the group 7 element on its own. It's the group 7 element on its own that will act again as gas only for those that are up at the top. There's 2 of them. There's fluorine and beta there's chlorine. Now, of the atomic masses provided, the only one that resembles of either fluorine or chlorine is the 35 and a half. So the answer here is D. 35 and a half referring to chlorine, 56 referring, I believe, to it's strontium and not barium, but nonetheless, strontium is also, again, an insoluble sulfate. All right? So remember, for group 2 sulfate, solubility decreases down the group. For group 7 halogens, boiling point increases down the group. Okay? All right, question number 4. Put a star by this one. Not because it's difficult, it's not. Because it is something that will most definitely show up this year on your examination. If you did not see it in P2, then you will most definitely be seeing it in P1. Or if you didn't see it in P4 IGCSE, you'll be seeing it in P2. And that is the ability to calculate relative atomic mass by, again, taking isotopes of any given element. Here, the 2 isotopes in question are 35 and 37. So if we want to look at the percentages to get to the abundancy, you've got to be able to understand. Look at what they've done. They've told you that the relative atomic mass is 35 and a half. So if the 2 values I have are 35, 36, and then 37, and my relative atomic mass is fitting there, the objective of understanding on this question is this, that if I'm going to get a relative atomic mass of 35 and a half, it will be solely due to the fact that, again, first, the AR is an average. You take an average of all of the isotopes present of a given element, and when you get that average, you calculate out 35 and a half. The second part of this is important to note, is if the average is 35 and a half, it means that there's a lot more 35 than there is 37. In this exact understanding, there's actually 3 times more 35 than there is 37. So that's why the answer here should be D. Now, some of you may be thinking, sir, we know this already because we've memorized it. That may be true, but beta bromine भी दे सकते हैं आप. और bromine में कह सकते हैं कि relative atomic mass 80 है. So then you would need to know that the abundancy of each is equal and it's 50-50. So don't be lured into the fact that they will only ask you about chlorine. They don't have to. But I believe that when they get the abundancies, they're going to probably pick on chlorine and bromine. Bromine, 35, 75%, 37, 25%, and bromine, 79, 50, and 81, 50. Other than that, if they give you a question on relative atomic mass, they will give you the abundancies and make you calculate the AR maybe to a decimal place. All right? So this is why the answer here is D. All right, question number 5. Another very particular question about knowing a lot of stuff at the same time. I love these questions because they test a lot of your knowledge at the same time, right? So, for example, it says that the oxide is simple molecular. Now, why is that important? Because it causes you to eliminate of the elements given, nitrogen, phosphorus, sulfur, and silicon. आप silicon को already हटा सकते हैं क्योंकि आपको पता है कि the oxide of silicon is macromolecular. It's a giant covalent molecule, right? Again, and then it says the information about their oxides. So it says that they dissolve in water to form acidic solutions, just so we're clear. That is a property of obviously acidic oxides. And non-metal oxides are the ones that are always acidic. So the answer is C, because you could do this with NO2, which is an acidic oxide. You could do this with any oxide of phosphorus, P4O6, P4O10, both of them being acidic. And you can do this with either oxide of sulfur, which again, both are acidic as well. Okay? All right. I've gotten a message and I will get to all of your questions. Just bear with me. Let us go in a sequencing manner rather than rush through. Question number 6, it says elements X and Y react to form a compound. Okay, fair enough. It says now X loses 2 and Y gains. First thing, right now, before anything else happens, in a question like that, your mind should already be thinking ionic, because they mentioned transfer of electrons, not gain, or sorry, not sharing. Then it says that X loses 2, and if X loses 2, then X has to be a 2 plus ion. It can't be anything but. It says that Y gains 1, so it's not that Y has to be minus 1. So now, if X is 2 plus and Y is minus 1, this is simply a compound where you're going to cross your valencies over and write your formula. And the formula should be XY2. The answer is B. Okay? All right. Question number 7. Which statement about graphite explains why it is used as an electrode? Very straightforward question. Nothing out here that sticks out. But here's a part that we want you to be able to keep in mind. This word electrode has a very specific meaning. The word electrode refers to any solid that conducts electricity due to freely moving electrons. So any substance, any solid that has the ability to conduct charge because of moving electrons, we refer to it as an electrode. So it is the fact that graphite has delocalized or freely moving electrons that dictates that fact that it conducts electricity. So the answer is D. Again, graphite has mobile electrons. That's why it will conduct electrical charge. All right? Good. All right, number 8. Again, star this one. I love this question because, to be very honest, I've been telling kids this for years. I said that they're slowly going to be sneaking A-level concepts, not exactly in the form of A-level, but concepts from A-level into O-level by making you take the knowledge that you have and applying it here. This is a very old A-level compound, CF3. It's a compound that we deal with where when we learn that not every, and this is where it gets tricky, not every compound that's made up of a metal and a non-metal will always end up being ionic. Some of them can be covalent. CF3 is a simple covalent molecule. The problem with boron is it's more like a non-metal or a semi-metal than it is like a metal. So for that reason, like silicon, it ends up sharing electrons rather than losing. Now the problem is it only has 3 to share, right? One boron atom only has 3 electrons to share. Yet, again, the fluorines are going to have 7 outer electrons, and conveniently, why it's VF3 is this reason. So this is what your fluorines do. Your fluorine atoms take their crosses and they end up sharing them with the 3 electrons that are present within the boron atom to begin with. So what you end up seeing is this BF3 molecule where the central boron atom is again sharing its 3 electrons with 3 separate fluorines, and each fluorine ends up with 8 electrons apiece. So now it's your job to go through the choices and make the one that's best to fit here. It is unusual for non-metals, it says set the fluorine to form covalent bonds. We know that that is completely off. The boron atom, each molecule, does not gain the configuration of a noble gas. That is the only statement that's correct. How can I tell? If I wanted it to be like a noble gas, it would have either been like helium with 2 or every other noble gas today. Boron only has 6 outer electrons. The other statements, covalent bonds do not consist of shared pair, again, goes against the definition. Fluorine atoms do not gain the configuration of a noble gas. I'm incorrect. They all, in fact, claim the configuration of a noble gas. So number eight is, in fact, B.